Hey there, my name is Dhaval Gupta and today I am going to teach you about momentum of inertia. There are two theorems of momentum of inertia. First is perpendicular axis theorem and second one is parallel axis theorem. So let us start with perpendicular axis theorem. Now then, let us understand what is perpendicular axis theorem. Perpendicular axis theorem states that the momentum of inertia along the axis perpendicular to the plane lamina is equal to the sum of the momentum of inertia along the axis perpendicular to each other on the plane lamina and which intersect each other at the point where the axis perpendicular to the plane lamina lies. So as you can see here, this is the plane lamina and this is the plane lamina. And the axis perpendicular to the plane lamina intersect the perpendicular axis on the plane lamina at the same point, and the momentum of inertia of the plane along this perpendicular axis is equal to the sum of the momentum of inertia along this axis and this axis. So let us prove perpendicular axis theorem. Now in the previous figure I have taken a point P which is at y distance from x axis, x distance from y axis. Now as PQ is parallel to AO and OQ is parallel to AP, so also angle AOQ equals to 90 degree. So we can assume that AOQP is a rectangle and we know that opposite sides of a rectangle are equal. So OQ is equals to X. Now as OQ equals to X, QP equals to Y and OP equals to R, and angle OQP is equal to 90 degree as it is a rectangle. Therefore by Pythagoras theorem the square of the hypotenuse, that is R square, would be equal to the square of the other two sides, which is x square plus y square. Now moment of inertia along x-axis of particle P would be equal to the mass of the particle P, let us assume it to be m, and the square of the distance between particle P and x-axis, which is equal to y square. Now similarly along y-axis moment of inertia equals to mx square. Also moment of inertia along z-axis would be mr square. Now adding moment of inertia along x-axis and y-axis, would be equal to my square plus mx square, which would be equal to my square plus x square, where we have taken y square plus m square in a bracket and m as common from the previous one. Now this would be equal to m r square, as r square is equal to x square plus y square. So we have put the value of x square plus y square as r square. Now we know mr square is equals to moment of inertia along z axis. So moment of inertia along x axis plus moment of inertia along y axis is equals to moment of inertia along z axis. And this proves the perpendicular axis theorem.